All right. Well, appreciate it. Thank everybody. One thing I want to call out is it's amazing to see how aligned we are as a group. It almost feels like we're working together in a group, OADT or something like that. My name is Kyle Daughtry. I've been at ExxonMobil for about 18 years, a bunch of different technical roles and digital over the last few years. I want to talk about this visual way of working. If you were in this with Michael, earlier, you would get a kickoff of where we're trying to move on this strategy, and I love how this whole group's come together. I want to focus on breaking the barriers to scale. All right, so let's see if this thing will move forward or not. I might have to control it. All right, so I wanted to take a really interesting position on this, and instead of going through a set of slides of what we're doing and all that kind of stuff, look at this from an area of debunking myths, or let's just say we'll become the digital twin mythbusters in this series together, and come along with me on the journey. I would love to hear arguments back and forth in the conversations later, but let's go on that journey. So first, myth number one. Digital twin is just a fancy 3D model. I actually love that representation whenever you had the collective of all the thoughts from people and 3D model is in the center. It's great, right? That's a good thought process at a high level, like a 3D model, a visualization. It's absolutely a part of a digital twin, but it is a part of that digital twin, and there are a number of other areas inside of our company, inside of many other companies that are maturing in this space of the top left-hand corner, this visualization, the simulation. Many organizations inside the company bringing together data and information to be able to better commoditize our assets. Bottom part of where we're pulling together data and information and enriching it, right? Providing context between 1D, 2D information. Great organizational work inside of the company, inside of our company, I know, and others as well. And then in the top right-hand corner, that aspect of visualization. And whether we call it digital avatars, digital twins, whatever we call it over a period of time, at the end of the day, it's this maturation of information and data. And I think that's probably the primary thing to talk about here is that, at the end of the day, what you're trying to get to is better understanding of an asset, whether you're in the field or above the field, and understanding that information. I love the conversation from Dan. We don't need to redefine a digital twin. You've already done that for us. Thank you for that. But at the end of the day, these are the things that start they're meaningful to us. Then is data and information and how it connects together. All right, myth number two. A digital twin is a software solution. This one's a fun conversation. A lot of folks will say, "Hey, I've got a tool for a digital twin," or "I've acquired a tool for a digital twin," and that's an interesting concept, right? But at the end of the day, you've heard it from everybody else here. A digital twin is not a singular tool; it's an ecosystem. Right? It's being able to pull together open and interoperable data across from engineering, from visualization to simulation, all the information above. Separating, if you heard from Michael earlier, separating that aspect of software from data, just like OPA started separating hardware from software. And no different here, right? One thing I want to focus on is this breakout of what we've been calling pillars. Capture, store, deliver, and consume. And that actually helped out a ton across our organization, break out those areas of how do we actually mature data in each one of those spaces. Whether on the left-hand side from capture, we democratize capture, or start moving as close as we possibly can to this little phone in your pocket and being able to acquire data instantly. And I'll talk a little bit about what we're calling that whole maturation a little bit later on. To storing it. In the past, you'd have hard drives sitting around. I don't want to spoil the end of this presentation, but if you haven't been in this space and you don't have a drawer full of hard drives, I think you're lying to yourself. And at the end of the day now, you are 100% able to move to this whole cloud-based instant access to information, instant upload. To delivering it, we've struggled in the past being able to pull together information and data consistently through a pipeline and being able to contextualize it. That's solved. And at the end of the day, the visualization of it or the consumption of it is anytime, anywhere. Whether you're trying to visualize the data for engineering purposes or for turnaround planning or emergency response, you might have different modalities of visualizing that information. Same thing from a modality of device. I might want to visualize it on a phone if I'm in the field, or I might want to pull it up on a PC at my home base, or in our remote offices for engineering. Biggest thing here is separate the software from data, allowing us to do plug and play and based on open and interoperable data. So that's myth number 2. All right, myth number 3. A digital twin source of truth should be an as-built 3D model. All right, this one is a really fun conversation as well. At the end of the day, absolutely, a digital twin is fed by the information that you give it. So you have, if you have an as-built, or if you have a model of a facility from greenfield to brownfield, it is absolutely a piece of information that gets tied in. But it isn't the only thing, right? It actually doesn't contain all the information that you need from an operations perspective in the first place. And there's more context, like we've been talking about here from a reality perspective, that allow you to get extra contextualization in that 3D space. It's this combination of pulling together information in space and time. And that's what defines the ability to be able to actually connect the information, not a single source from either reality or a single source from a 3D model. And you mentioned it already, Nick, that the cost to be able to do this at scale from a reality capture perspective is, I think we estimated like 10x over the last 3 years. It's dropped to about 10x, and it'll do the same thing, 10x even lower over the next 3 years. All right, myth number 4: data exchange for digital twins have been solved. That's a good myth. It's actually a great thing to talk about because there are wonderful efforts that are going on in industry to try to solve this, whether that's DXB for drawings, or IFC or FL3EMS for models and that information. But I would say just because the things exist there does not mean that we're done solving this. So this is a reverse on that. There is still a lot to solve within the standard space. I love this graphic. We've shown it for the last couple of years on the right-hand side of looking at other industries, tangential industries, and what they're doing to be able to solve this problem. From the media and entertainment and the Department of Defense, you can't come into a conversation from their side without being able to do interoperability of data and information. It's not perfect. Nothing's ever perfect, but absolutely, they've got a highway system, and the further and further you go down in this, you'll start seeing that it might be a little bit provocative, but in our industry, we might have a canoe or a slight motorboat. And this whole group, that's what we're trying to do, is continue to mature that model upward and say, how do we make interoperable data and work with the right consortiums to position ourselves to be successful. All right, I'm going to go past this just from a time frame perspective and hit on myth number 5. Digital twins only bring value during project phase. Now, this group here, I understand that it's not just a recognition of project phase being the only way to capture value, but one of the things we did towards the beginning of this open asset digital twin was we did a study of all the use cases across all of our organizations. And a large number of those came out, right, of value cases in ops and maintenance, reliability and engineering. One of the really interesting things from there was there's a interesting shift, and Nick, you kind of alluded to it, that there's a lot of value to get from the reality capture aspect of information and data and starting to layer in information over a period of time. That same thing started coming out from our study to understand that there's value in reality. There's value in being able to understand what reality looks like at all points in times, or at least knowing what's changed over time. All right, this is the last myth, and one that's probably nearest and dearest to my heart, is that managing reality capture at scale to support a digital twin is too difficult. I don't believe that. Not only do I not believe that, it's not true. And I want to break that down in a couple of areas. So I'll do it based off of those pillars that we talked about: capture, store, deliver, and consume. And from the capture side, let's just take an example of, I don't know, this could be stockpile management, or I'm doing a scan for a turnaround. In traditional scenarios, I would go out there and I'd have a survey crew go out and do a survey. You'd take a total station, do measurements, and you have a crew maybe of 2 or 3. This now, in terms of our cockpits, is automated. Drone capture on target, on survey control, automated. So the time to do this, the resource to do this is instant, nothing. From the storage pillar, I've mentioned the hard drives before. Again, yeah, if you don't have a stack of hard drives, you probably haven't been in this space. But that is massively changed now. We're talking about reduction of times and upload to the cloud and being able to access that information in seconds. There's actually a really interesting thing that we're working on with industry right now that just pay attention later this year. We'll talk about an effort of us trying to come out to industry and boost the industry within this space to make it even faster and easier. All right, and that deliver. If you've seen some of our presentations in the past, that little baby has followed us with a spaghetti bowl on his head for quite a while. One of the first things that we did was we were looking at, well, what does an ecosystem of connecting this information look like? And whether you're looking at it from the lens of engineering, design, emergency response, or any of those other particular scenarios, the data and interconnectivity was always pretty hard to deal with. How do you actually connect data sets that were disparate or in different systems? And one of the biggest things that we've been working on is creating an instant and easy pipeline to be able to access your information at all points in times. So you've got the road. You start to get the roadways now of being able to say I've acquired data for a turnaround, and I can use that same thing for emergency response scenarios. And that's all based off of 3D pipelines. So it's not something that I'm doing manually. It's something that's automated. And then finally, from that aspect of having data and information ready to you on a tablet or a phone or on a PC, what this looked like in the past was do the acquisition, spend a week or 2 to do the post-processing of information, then post the information to a person to be able to do some QC on it, and then ultimately you get analytics on the outset of it. And the really cool thing, and this is kind of a now but almost a future, is I can literally do stockpile management via my phone by just scanning for 10 seconds or so. Now that doesn't work in all scenarios, but you can see where the technology is going. I'm not having to put any thought into this. So it's either a drone that acquires the stuff, or if it's something simple and small enough, I've got access to a phone that can give me all the information and data instantly. Let's see. There we go. All right. This whole component here of being able to bring together reality to you faster is something that we have been coining mean time to reality, or MTTR. And it is a fun play on words of mean time to repair. Same concept of how do I get access to information and data faster and easier in reality. And this whole pipeline and set of pillars is built based off of that. Hopefully I helped explain a little bit of how we're actually pushing that forward today. Please come join on that journey, because we're going to continue to push it into the future as well. One last thing that I want to throw up here is all the action. You see a bunch of passionate folks up here. There's more. Please promote interoperability within systems. It's the only way that we're going to be able to scale. It's scalable for both a supplier ecosystem and an owner-operator ecosystem. Separate the hardware and software from data. That's at the core of us being able to actually access our information at any time, anywhere. Advocate with EPCs for data exchange and design tools. I think that's a big portion of work that we've been working on as well. Happy to dive into that a little bit more. And honestly, unite with this group of people that are passionate about trying to push forward information so we can see reality at any point in time. Thank you.